So based on the example, you can see what you're expected to do. So I'm just going to go through and do exactly what the example does, but with the number 78. So you take the number 78, and then you reverse the numbers and get 87. When you add those, you get 165. Now we take the number 165. When we reverse those, we get 561. When we add those, we get 726. Now you take 726. When you reverse that, you get 627. And we're going to add that. And you get 1353. None of these numbers are palindromes, so we're going to keep going. So we take 1353. When I reverse that, I get 3531. And I add that. This number is a palindrome. And so that is the palindrome we eventually get if we start with a 78. So this next question, a lot of you struggled with it, and I think it was just in how it was worded. Really, especially if you're in grade 7, you just finished doing this stuff, which is factor trees and breaking numbers down into their prime factors and then writing it in exponential notation, which is exactly what this question is. So take the number 2016 and let's break it down into prime factors. For example, we could do 504 and 4. We could take 504, break it down into 126 and 4. It really doesn't matter how we break it down, right? We're just using a factor tree. So we could have 42. Whoops. We could have 42 and 3. And then this could get broken down into 6 and 7 and 3 and 2. 4s are 2 and 2 and 2 and 2. So now, how many 2s have we got? We've got 1, 2, 3, 4, 5. So that's 2 to the 5. We have 2 3s, so that's 3 to the 2, and we've got 1 7. So it says, what is the simplified value of a to the b plus c? So a is 5 and b is 2, so a to the b plus c. You get 26. So actually, this question, it seemed really hard based on how it was read, because he had letters and it was like, oh my gosh, what do I do? All it is basically saying, break 2016 down into its prime factors. That's really all it's asking you to do, and then fill in the formula. So this one, an edge, remember, is this part here. So it says some of the edges are to be colored red, so that each face has exactly 2 red and, let's say, 2 black. So if you just look at what I just drew, that means that top face, 2 red and 2 black. Well then, if I do the side face, there's my 2 red, there's my 2 black. If I do this face, oh, wait a minute, can't do that because I've already got my 2 black. So I've got my 2 red. If I repeat this, what you're going to notice is that for every square, for every face, and there are 6 faces, for every face, if 2 are red, there must be 2 black or some other color. It doesn't really say what color. I'm going with black. Because every face is a square. So if 2 of them are red, then 2 are something else. So that means that if there are 12 edges, I must have 6 red, because each has 2 and 2. So all I have to do is do 12 divided by 2. So this one here, you have to understand what 7 consecutive whole numbers means. It means numbers in a row, like 5, 6, 7, 8. Those are consecutive whole numbers. So this one here tells you that you have 7 numbers that are consecutive in a row, and when you add the first, the third, and the sixth, you get 175. That just gives you a hint as to where to start trying. So for example, if you started at 10, you're going to be too low. If you added those up, you're going to be too low. An idea of when you have consecutive numbers, to give you a ballpark of where to start, take the number that they add to and divide by how many there are. So there are 3 of them. When I take 175 and divide by 3, I'm going to get 58 and a bit. So that gives me a starting point. It gives me an idea of where I think I might want to start. I'm going to start with numbers around there. And then I kind of use a little bit of guessing and checking to figure out what the numbers are. So it actually turns out that the numbers are going to be 56, 57, 58, 59, 60, 61, how many is that? 1, 2, 3, and 62. So those are my numbers. The first, the third, and the sixth. When I add those, I get 175. The question was, what does the other 4? What do the other 4 add up to? When I add up those other 4, when I add those, I get 238. The key was really just knowing where to start. And really, you could have tried anything and done a bit of guess and check. And so if I started with 10, for example, I know I'm too low, and kind of make some guesses based on that. But this strategy gives you kind of a starting point. So obviously, it didn't start at 58, but 58 was one of the numbers. So it gives you an idea of some of the numbers to try around. So we've got one more left, and that's this one. Now, at first, this one sounds kind of confusing. You have you can get nuggets in a size pack of 4, in a pack of 7, or a pack of 17. At first, it seems like there's going to be a lot of numbers that are not going to be possible. But in actual fact, with these kinds of questions, you're going to reach a point at which you will be able to make any single number using these combinations. So I'll show you as an example. So first of all, obviously you can't get 1, 2, or 3. That's not possible. You can't get 5 or 6. Let's try to think about what you can get. Well, we can get 4. And if we can get 4, that means we can also get 8 and 12 and 16 and 18 and 22 and so on. We can also get 7, which means I can get 14 and 21 and 28 and 35 and so on. Now remember, I can get 4. So I can add 4 to any of these things that I just did. So like I can do 4 plus 14 and I can make 18 or 25 or 32 or 39. Okay? I can also, oops, I actually made a mistake here. I just noticed this should have been 12, 16, 20, 24, and so on. Now, I can add 7 to any of these things that I just created. Like, I can make that 11. And then I can make this 15, and I can make this 19, and I can make this one 23, and I can make this one 27, and so on. Keep in mind as well that I've got 17, which I can add 4 to, and I can make it 21 and 25. I can add 7s to these and make it 24, and so on and so forth. When I start to actually list all these numbers, what I'm going to start to find are a few things that are going to always be possible. So in that, what I notice is, for example, I can make 14. I can make 15. I can make 16. I can make 17. Now, a really interesting thing happens now. If I can make 14, I can make 18. If I can make 15, I can make 19. If I can make 16, I can make 20. If I can make 17, I can make 21. Well, if I repeat that, so 18, 19, 20, 21, if I can make 18, I can make 22 and 23 and 24 and 25, and guess what? You just reached a point at which every single number is now going to be possible. So now what we need to look at is what's the biggest one that was not possible. So if I look at my list, I can make 11, I can make 12. I don't see a 13. And so when I look at these numbers, there is no way with these 3 numbers that I can make 13. But beyond 13, I can make every single other number that exists. And so the answer to this question is 13.